should be very much careful when we are discussing all this. Okay, so this is NFA. So we have discussed that finite automata are of two types. One is deterministic, another is non-deterministic, and hence they are called as DFA and NFA. Now we are going to discuss about one variation in NFA, that is with epsilon transitions. Now till now whatever finite automata we have discussed, in that we had in that we had what? The transitions are happening due to some input symbol, or if any input symbol is there, then and then only the transition is happening from one state to another state, right? So now this is a special kind of NFA in which the transition is possible without any input symbol. Okay, so here we say that NFA with epsilon transition, that include transitions on the empty string. Understanding? So without giving any input symbol, that is empty string or empty input symbol. Okay, that is denoted by this. Okay, epsilon. This is also known as NFA with epsilon moves. Okay, so epsilon transitions or epsilon moves. Okay, so what is the formal definition for this? So all finite automatas are represented by the 5 tuples. The formal definition is, we are representing NFA with epsilon moved by 5 tuples, that is M is equal to same Q, alphabet, delta, Q0 and F. Now the definition of all these tuples or all these parameters will be differing, okay, depending on type of FA. So DFA we had seen that the delta function is different. In NFA also it is differing as different delta function. Similarly, when we are having NFA with epsilon move, we'll be having the variation as compared to earlier discussed finite automata. So here Q is representing same thing, that is finite set of states. So I am not writing once again. You should copy. Okay, what is Q? What is Q? What is alphabet input symbol or input alphabet? You can say what is Q0? Your initial state. What is F? It is nothing but final state, set of final states which we have already discussed. And finally, there is a change in the delta function. So what is the delta function for NFA with epsilon move? It is nothing but Q into alphabet, and not only alphabet, as the transition is happening with the epsilon, that is without any input symbol. See, empty string or empty input symbol also the transitions are happening, right? So here we will be having union this. Okay, and this is going to move to a how many state possible state, since it is a NFA. Okay, it is not a DFA, it is a NFA. So we know that there is a possible that it can reach to 2 raised to the power q states. Okay, so in this way we are representing the delta function of a NFA with epsilon. I hope this is clear. Okay, so now NFA with epsilon transition, the very common example which is also asked for the different types of solutions or different types of problem. So same example I'll be discussing. Now one of the example is, see here, you have a start state, then the transition is happening with the epsilon move. Okay, there is a some transition happening with the input symbol 0. Next, it is reaching to Q1. Again, with epsilon move, it is reaching to a final state named as Q2. Okay. Now, here there are more transitions, like with the input alphabet 1 and here 2. So from this figure, can you identify the Q? What is your Q? Yes, answer me. What is your Q set? How many states are there? Can anybody? So it is Q0, Q1 and Q2, right? What is your alphabet? So it is having 0, 1 and 2. There are 3 alphabets used in this example. Next, what is your initial state? The initial state is Q0 in this case also. And then what is your final state? So your final state is Q2, right? And what about a delta function? So your delta function will be represented by a table in which again we will be having entry just like we had in the earlier examples. So here we will be having the alphabet, as well as, since this is a delta function representation, we need to also consider one extra column for this empty string, right? So here we will be writing all the states like Q0, Q1 and Q2, right? And the entries will be for how many? So how many columns will be there? As many input symbol plus one more column. So it is how many input symbols? 0, 1 and 2, and one extra for empty string, right? So in this way our delta function will be represented. In this delta function, as you can see, we can also write all the entries. You know already how to write the entries. So how you will write the entry? Tell me this part. So Q0 on 0 moves to, yes, anybody? Q0. Q0 on 1 moves nowhere. Q0 on 2 moves nowhere. And Q0 on empty moves to Q1. Right? Any problem? In this way only you will represent a table. Okay. Next is, you are having next entry as what? Q1 on 0 moves nowhere, so you can write here 5, 5, 5. So Q1 on 0 moves nowhere, Q1 on 1 moves to Q1, Q1 on 2 moves nowhere, and Q1 with empty string moving to Q2, right? Next, Q2 on 0 moves nowhere, Q2 on 1 moves nowhere, Q2 on 2 moves to itself. Okay. Then any more entries you are finding here with empty string? Are you getting any more transitions? No transition for empty string, so try again. So this will be the representation for this example. Now the question arises, we have drawn finite automata and we have discussed also one example. That example had been uh, designed for, or it was a finite automata which is accepting a language which is having even number of zeros and even number of ones, right? Now we have discussed about finite automata, DFA, NFA. They are also designed for the same purpose, that is nothing but acceptance of certain languages. So when we are talking about certain languages, so we need to have certain examples of it. Okay. So we will be discussing after completing this part, we will be discussing about the different examples, how to construct the finite automatas. Okay. So now question arises, what is the significance of NFA with epsilon moves, why they are required, when they are used, when to design such finite automata. So you should know all these things. Okay. So as a outcome of this subject, you should be able to identify which type of finite automata will be constructed to see the acceptance of a particular language. Okay. So for this, what is the significance here? So for example, I want a language in which the, see, I'm writing a definition. See the example. Suppose there is a language which is a set of strings with zero numbers of zero, or we can say no, zero or more number of zeros followed by zero or more. So this is zero means this zero. Zero or more number of ones followed by zero or more number of twos. So what is the purpose? The purpose is we want a language in which it will be having zero or more number of zeros followed by zero or more number of zero. Zero or more number of ones followed by zero or more number of twos. So what will be such language? When it is having zero or more number of zeros. Okay, that means no zeros are present, followed by zero or more number of ones. That means if it is having again zero number of ones, then no one will be there. Similarly, followed by zero or more number of twos. Okay, that means again 2 is not there. That means even if there is an empty string, that is without any input symbol also, your transition will happen. See here in this thing, Q0, you will be at Q0 without giving input symbol, you are reaching to Q1, right? So this is the significance of whether the string is having any number of 0 or not, but if it is having 1 or 0 or more number of ones or 0 or more number of twos, then also you are reaching till the final state. Once you reach final state, that itself indicates that particular string is acceptable. So if we follow path like this, Q0 without any input symbol reaches to Q1, Q1 without any input symbol reaches to Q2. Once we reach from initial to final state without any input symbol, so we can conclude that the empty string is acceptable to this finite automata.